Okay, sixth years, I wanted to run through video corrections for the problems I'd given you on Thursday. So I'd given you question 1, 2, 3, and 4 from the textbook from page 250, I believe. Now I'm going to do corrections for question 1, question 3, and question 4, because question 1 and question 2 are pretty much identical. So I'm not going to run through question 1 and 2. I'll just go through number 1 and hopefully be able to use that to fully correct question 2 for yourself. So this is question 1 here on the screen. As you can see, we've got a chicken coop is enclosed using 40 meters of fencing. And it says the enclosure is rectangular. So we can see the shape. We have each side, we have the length and the width. Length being 20 minus x and the width being x. So part 1 asks, if one side of the enclosure is x meters long, explain why the adjacent side is 20 minus x meters long. So there's a bit in this, and it's nothing really to do with the differentiation or anything that we've been doing, but we should be able to just figure out what's going on. So I have my corrections here, and just to show you, you can see, hopefully, I've redrawn the diagram here. Okay, so we got x on either side as the width, and you got 20 minus x as the length. And as I said, it told me in the question, I'll get rid of that. It told me in the question that all sides, or the perimeter, is 40 meters. So all sides added together gives us that 40 meters. So what I've written here for part 1, because the perimeter is 40 meters overall, okay, we know that half of that, imagine, let's say this side and this side, the two of those added together must be half of the perimeter. So we can say that x plus the 20 minus x is equal to 20 for 2 reasons. 1, because it's half of the perimeter, and 2, because x minus x cancel, and I'm just left with that 20. So I've explained there, and you can see, hopefully that works, that makes sense for you, because our perimeter is 40 meters. 2 of the sides, one of the lengths and one of the widths added together are equal to the 20 meters. Going back to part 2, find in terms of x the area. So area, nice and simple, okay? We know that area is length by width. Length by width. So based on this, I got to do that times that, okay? Nice and straightforward. And we can see it there. I've done x by 20 minus x, and I've got my area, okay? Multiply that out. X by 20 gives me 20x, and x by minus x gives me minus x squared. And you can see I've also put in my unit, meter squared, just in case, okay? Then, now we're getting on to the differentiation part, so the stuff that we've been doing most recently. Find the value of x that maximizes the area. So I'm talking about the max area of the enclosure. So the way to do this, okay, I have my area, I have my formula for area, which was 20x minus x squared. So the way to do it is, first and foremost, that represents the area. What I got to do is I get the first derivative of that. So I'm differentiating area with respect to x. Okay, so I get my first derivative of that. I have it on the next slide, I'll show you in a second. And then I'm going to put that equal to 0, because that gives us our maximum value. When our first derivative is equal to 0 is our max value, okay? Because that's where the y would be equal to 0 if you're talking about it in a graph. Alright, so where our y is equal to 0, that will be our maximum x value. We'll find that out. So what we got to do, you can see I've written it here. I'm differentiating area with respect to x, dA dx, dA over dx, I should say. So we got our area formula. I get my first derivative, nice and simple. So I get 20 minus 2x. Again, if we're not comfortable doing derivatives, we got to go back and check it again, because we've done that a long time ago now. So the way to do it, as I've said, we let the dA over dx is equal to 0 and solve for x. So I've got 20 minus 2x is equal to 0. And then I solve for x, a little bit of algebra, moving everything around, and I end up with x being 10. So x is 10 meters. So then I can pop that back into the formula, or back into the diagram that was given to us at the start. Remember, we had that was x, and that was 20 minus x. So I've done 20x is 10 and 20 minus 10. So that gives us each side to be 10, which is actually a square if you think about it. Now it said in the question that the shape was rectangular, but a lot of these end up with a square as your answer, to be honest. So the last bit is part 4, and it says what's the maximum area of the enclosure. I now know what my x value is. Okay, so I know that this side is 10 meters long. I know that this side is 10 meters long because it's 20 minus 10. Okay, so all I got to do to figure out the area, I know what these numbers are, and I just got to multiply those together to get my area. 10 by 10, 100 meters squared. Don't forget your unit. Okay, and that's it. So you can see what we had to do. We figure out what the area is in terms of a formula with x in it. We differentiate it. We put it equal to 0. And we solve. Okay, so that's usually the process here. So question 3 is very similar. Okay, and again, we can see, because if the width is x, find in terms of x the length of the rectangle. So look, it's telling me that it's all equal to 100. So you can imagine this and that are the two widths, and overall that has to be 100, doesn't it? So you could say a couple of different ways I can do this. Okay, I could say this side plus this side is equal to 50 because it's half of the perimeter and the perimeter is 100. So I could say that if this is x, then this side has to be 50 minus x. I could do that, which means that would be 50 minus x as well. That's fine. Okay, alternatively, you can see the way I did it here. You would know that the perimeter overall is 100 centimeters, as I've written. So if I'd say 100 is the full perimeter, okay, imagine a full lap around the rectangle. So if I take away those two x's, I'm just left with the length and the other length. So I've got 100 minus 2x is equal to twice the length. But if I'm not looking for twice the length, I'm only looking for once the length, I have to divide that answer by 2. So I've got 100 minus 2x divided by 2 would give me 50 minus x. Now, I think the way I've done it up here is probably a little bit easier. But just to show you a couple of different ways you can start that off. Part 2 asks, okay, so it's giving you your answer. Show that the area of the rectangle is given by this value. So I want to make up a formula. I want to multiply it out to get my area of the rectangle, and I want it to be equal to that. If I don't get that, I've made a mistake. So I've got my length and I've got my width now. Okay, I know that the width is x. I know that my length is 50 minus x, like we got in the previous part. So I'll just multiply those two together. So you can do x by 50, give me 50x, x by minus x, give me minus x squared. And that's what was given to me in the question. Hence why I got my 2 ticks there. I'm very happy because it told me what the answer was going to be and I've worked it out. Part 3 then. Same as we did in question 1. It asks, find the value of x that maximizes the area. Okay, so this is exactly the way that we're going to do this as normal. We're going to use the area formula. Remember, I've got my formula. I'm going to differentiate it. I'm going to differentiate it. I'm going to put that equal to 0. And I'm going to solve. Solve. Alright. So, I've got my area formula, 50x minus x squared. Happy with that. I'll differentiate it first and foremost to get to 50 minus 2x, and then I put that equal to 0, as you can see, and I solve for x. So x in this case is equal to 25. So as I can say, like you did in question 1, I end up with a square as opposed to a rectangle. Okay, because I know each side is x. The widths here are x, and I know that these are 50 minus x, which is 50 minus 25. 50 minus 25. 50 minus 25, as I've said, which is 25. So that looks like, again, I've got 25 meters on all sides. and that gives me a square again. Part 4 asks find the maximum area. If I know what the values are on the length and the width, all I got to do is multiply them. So I do 25 by 25, and you can see that gives me the 625 meters squared. Finally, question 4. An enclosure is in the shape of a rectangle. One side of the enclosure is fenced in by a building. So 100 meters of fencing is available to fence the other 3 sides. So I'm talking about 1, 2, 3 sides are fencing. Okay, so this is X. This side is also X. And that's what we know so far. Okay, so I've only got fence and the yellow part here, here, and here. All right. If the width of the enclosure is X meters, find in terms of X the length of the enclosure. So I want to figure out what that length is. Nice and straightforward here. Okay, I have my drawing again. I can see 1 plus 2 plus 3 is equal to 100. Those 3 sides. So the length of the fence, or the length of the enclosure. So this distance here has to be 100 minus those 2 X values. All right, so it's 100 minus 2X. Done. All right, so that's all there is to it. Next part. Show that the area of the enclosure is given by A is equal to 100x minus 2x squared. Again, show. So I've been given my answer. I just got to make sure I get that. If I get that, I know I've done it fully correctly. And again, I'm getting area, so I've got to do length here by width there. So I'm going to do this times this, and I know what each of those 2 represent now. X is my width, and I know that the length is 100 minus 2x, so I just multiply those out. 100x minus 2x squared, and again, that fits what was given to me in the question, so we're happy. Part 3, go back to the question. Find the value of X that maximizes the area of the enclosure. Maximizes the area. So remember, I get my first derivative, I put it equal to 0, and I solve for X. So I've got my area formula that I've worked out in part 2. I get my first derivative, I put it equal to 0, and I solve for X. Okay? And you can have a look at that. You can pause it if you want to, whatever you need to make sure you can have a proper look at those again. But, so now I know that X is equal to 25. I can say that side's 25, that side's 25, and the length was actually equal to 50. And the final part, it asks find the maximum area of the enclosure. Again, the enclosure is length by width. So 50 by 25 or 25 by 50. And it gives it that, again, unit meter squared. Be careful. Okay, so that's question 1, 3, and 4. I'm posting up what you guys need to get done for today for me, and we'll be live to answer questions via email or via messages if you're interested in that at that time. Thank you very much.